Have you ever wondered what makes magnets stick together or cling to your fridge? It feels like magic, right? Tanda. But the truth is even more fascinating than magic. Okay, it's all about something happening at a level so small you can't even see it. Today, we're diving deep into the world of magnets to uncover the secrets behind their mysterious pull, from the tiny particles that give them power to the incredible ways we use them to change our world. Get ready to have your mind blown. This isn't just a science lesson. It's a journey into an invisible force that shapes our daily lives in ways you've never imagined. So, why do magnets stick? The simple answer is an invisible force called magnetism. But to really understand it, we need to zoom in, way in to the atomic level. Imagine that every material is made up of countless tiny magnets. We call these microscopic regions magnetic domains. In most everyday objects, like a wooden table or a plastic cup, these tiny domains are all pointing in random directions. They're a jumbled, chaotic mess, canceling each other out. The North Pole of one points to the North Pole of another, the South to a South, and so on. The result? No overall magnetic force. It's like a huge crowd of people, all shouting at once. You just hear noise, not a clear message, okay? But in a magnet, something special happens. So all, or at least most, of these magnetic domains are neatly lined up, all pointing in the same direction. It's like that chaotic crowd suddenly forms a perfectly organized choir, all singing the same note. All those tiny magnetic forces add up, creating one large, powerful magnetic field that extends out from the magnet. This field has a North Pole and a South Pole, just like our planet. And that's the key. When you bring another magnet close, their fields interact. Opposite poles, a north and a south, are irresistibly drawn to each other. It's this attraction that creates that satisfying snap when two magnets stick together. On the flip side, if you try to push two like poles together, like two North Poles, they'll push each other away. You can actually feel the invisible force resisting you. What's truly amazing is how we can create magnets. We can take a material like iron, which has these magnetic domains, and expose it to a strong external magnetic field. This strong field acts like a drill sergeant, shouting at all the jumbled domains to get in line. As they realign and point in the same direction, the iron itself becomes a magnet. This process is how we make the permanent magnets we use every day, from the ones holding up your shopping list to the powerful ones inside machines. It's all about creating order out of chaos at a microscopic level. Now, let's talk about something that can mess with this perfect alignment: temperature. Have you ever heard that heat can weaken a magnet? It's completely true. Think of temperature as energy. When you heat a magnet, you're pumping energy into its atoms, causing them to vibrate and move around more frantically. This chaos disrupts the neat alignment of the magnetic domains. It's like that perfectly organized choir suddenly breaking into a wild, disorganized dance party. The more they jiggle and shake, the more they lose their alignment. Okay, if you heat a magnet enough, you can reach a point called the Curie temperature. Where the domains become so jumbled that the material loses its magnetism entirely. It just becomes a regular piece of metal again. This is why magnets used in high-temperature environments, like in certain engines or industrial equipment, have to be specially designed to resist the effects of heat. Cooling a magnet, on the other hand, can sometimes make it stronger as the atoms vibrate less, allowing for an even more stable and perfect alignment of the domains. So we know what makes magnets work, but where do we actually use them? The answer is almost everywhere. Applications are so widespread and vital that modern life would be impossible without them. Let's start with sound. The music you're listening to right now, magnets are making it happen. Inside every loudspeaker and headphone, there's a magnet. An electric current carrying the audio signal passes through a coil of wire attached to a cone. This coil is placed near the magnet. The interaction between the magnet S field and the electric current S field causes the coil to vibrate rapidly. These vibrations are transferred to the cone, which pushes the air and creates the sound waves that travel to your ears. From the deepest bass to the highest treble, it's all powered by the dance between electricity and magnetism. It's a brilliant piece of engineering that turns invisible signals into the music and podcasts we love. Let's move from sound to sight, specifically medical imaging. One of the most groundbreaking medical technologies of the last century is magnetic resonance imaging, or MRI, and as the name suggests, it relies on incredibly powerful magnets. An MRI machine uses a massive superconducting magnet, thousands of times stronger than a fridge magnet, to create a uniform magnetic field around the patient's body. This field aligns the protons in the water molecules of your body's tissues. Then, a radio frequency current is pulsed through the patient, knocking these protons out of alignment. When the radio frequency is turned off, the protons relax and realign with the magnetic field, releasing energy that is detected by the MRI scanner. Different tissues realign at different rates, allowing the machine to create incredibly detailed, cross-sectional images of your organs, muscles, and other soft tissues without any invasive surgery. It's a life-saving technology that allows doctors to diagnose conditions from torn ligaments to brain tumors, all thanks to the fundamental principles of magnetism. The power of magnets isn't limited to delicate tasks like creating sound or images. They are also industrial powerhouses, scrapyards, recycling centers, and steel mills. You'll find enormous electromagnets attached to cranes. These aren't permanent magnets. Their magnetic field can be turned on and off with a flick of a switch. When the electricity flows, the crane becomes a super strong magnet capable of lifting tons of scrap metal, cars, or steel beams with ease. It allows workers to sort and move heavy, often sharp, materials safely and efficiently. Once the material is in place, the operator simply cuts the power and the magnetic field vanishes, instantly dropping the load. This on-demand strength makes electromagnets indispensable in heavy industry, demonstrating the raw power that magnetism can command. Magnets are also the heart of electric motors and generators, which power everything from your blender to electric vehicles and the power plants that light up our cities. In a motor, magnets create a field that interacts with an electric current in a coil, causing it to spin and generate motion. In a generator, the process is reversed. Mechanical motion, like a spinning turbine, moves a coil within a magnetic field, which generates an electric current. This beautiful symmetry between electricity and magnetism is the foundation of our entire electrical grid. And what about data storage? Old school hard drives and computers use tiny magnetic domains on a spinning platter to store your data as ones and zeros. Even today, the magnetic strips on your credit cards use the same basic principle to hold your financial information. From the compass that guided ancient explorers to the advanced technologies that will shape our future, magnets have been humanity's silent partner. They are a fundamental force of nature, an invisible power that we have learned to harness in a million different ways. The next time you snap a magnet onto your fridge, take a moment to appreciate the incredible microscopic ballet happening inside. It's a world of perfectly aligned domains, working in concert to create a force that drives our world forward. It's not magic. It's the elegant, predictable, and utterly fascinating science of magnetism. Thanks for joining me on this journey into the invisible world of magnets. If you found this as cool as I do, be sure to like the video and subscribe for more deep dives into the science that surrounds us. See you next time.